documenting the front lines of the AI revolution, the AI Rebels podcast.
Hello, everyone, and welcome to another episode of the AI Rebels podcast. I am your co-host, Spencer.
And I'm your other co-host, Jacob. And we are very excited to have James Villarrubia. I said it right, James? Villarrubia?
Yes.
You're on the show. Excellent. With us today, who has a fascinating background and such a wide breadth of experience. We're very excited to have you on, James. Thanks for coming on.
Oh, no. Thanks for having me. I'm really excited to chat.
James, can you give us, obviously you've had so many different experiences, but can you give us like an arc of your career in
Sure.
AI and your experiences?
Yeah. It's as you hinted at. It's a weird arc. It's a strange story. So I studied systems engineering at the University of Virginia. Go Wahoos! I realized like the coolest problems were always public policy related. So I went and got a master's in public policy, not realizing that the heavy stats and sort of the heavy linear algebra that is required to be a system engineer would lend itself really well to sort of a future in sort of AI. So when I graduated, I was a fellow for the Pentagon working on some Joint Chiefs projects. And I think I started what feels like the running trend, the theme, the thread of my career was jumping into projects that were maybe a little bit on fire, or things that were in moments of serious change, is like the euphemistic way of putting it. And I was like, look, I'm young, I'm in my early 20s, I have no career reputation to ruin yet, so let's do this. So
it's all up.
Right, because it's all up, because these are projects where if you succeed, great, and if you'll be a king among men, and if you fail, no one will care because you were a 20-something and you probably didn't know any better anyway. So one of the projects took me to the Middle East, where I was doing sort of troop tracking in the midst of the Iraq and Afghanistan war. Like, we have all this data, why is it wrong? How do we fix this? And trying to build, very simple regression models on secure computers without but Excel, but it's like Excel from like 10 years ago. Wow. You can't run macros, you're doing it all by hand. So it's, take me back to like that manual math. It's like, all right, I'm going to do this by hand, but we're going to crack this. And I came back with some moderate success on those projects. And then sort of Fukushima happened. And then had an opportunity to go to the White House on behalf of the DoD and say, hey, we need someone who understands energy policy and can talk like modeling with some of these MIT researchers, modeling this radioactive plume of cesium spreading through the Pacific, but also speaks Navy and DoD policy. And the Venn diagram of people who fit there is just pretty small.
They're like,
and I was cheap.
You're the one.
And I was like, all right, you're the guy. You are willing to stay up, to all hours of the night and talk to this team in Japan, and then prep something for like the presidential daily briefing. And I got my one bullet point in the PDB, like, do we need to evacuate, California? No. Okay, great. But there are lots of really interesting like problems that you didn't expect in that, around sort of like driftwood and all these things that would take 3-4 years to make their way from Japan to the US, but were coated in cesium. If you're trying to solve these like really interesting policy problems that involve also a lot of stats, and loved it. That project wrapped up. And went over to the Department of Justice, doing large scale IT procurement. But I remember sitting across from the team at Microsoft, and they were selling Microsoft Cloud, GovCloud. I don't think there was even Azure yet, right? It was just like GovCloud. And I was like, oh man, like this is really cool. I want to build with this. I don't want to just buy this. So I left and restarted my career as more of a sort of software developer, and then went to like a cryptography company out of India and Hong Kong, then came back and did human capital analytics and AI in New York, some dabbling in sort of some deep learning models around some human capital surveys. Can you predict if people are going to quit based off of like how based off of like the policy for like, do you allow your workers to, go to the vet with their dog if their dog is sick? And how much does that impact their willingness to quit? Surprisingly, a lot. So, trying to find these sort of weird little nuggets of truth that were sort of buried in these surveys, and then redesign the surveys to sort of pull out more weird things. It was really fun. And this was all right before the pandemic, so it was really well timed. And then I did education in AI, because I was like, hey, I'm doing all these surveys. Can I apply this to learning and efficacy in K through 12? And then had the chance to go work at a healthcare company right before the pandemic, which was a different adventure. So joined healthcare and suddenly knew nothing about healthcare, but suddenly the pandemic hit, and I was suddenly having to learn how how these very old school, like 1990s technologies were like transmitting data, how we could leverage AI. I had some really great partners on the data team there. And we were just trying to tackle like, how do we optimize just getting through the volume of COVID tests on this like legacy on-prem stack? Like there's, water dripping down from the corner. It's terrifying. So we need to get to the we need to get to the cloud, but we also can't do it quickly. But we need to deliver something now. And it was chaos, 90, 100-hour weeks. But it was really, again, you also know that like every hour that you kept the system running, it's always like just at the edge of disaster and fire. But every hour you kept it running, more COVID tests would get delivered. And you could do the math in your head very quickly. So, okay, that's how many people don't have a delay in their notifications. Okay, that's X many fewer infections. Okay, that's X many fewer deaths. And you're like, when you're doing, like, if you know the math, you're like, oh man, every hour I keep the system running, if it's at the brink of failure, if it stays up, this is how many people will not die. And that was like
amazing.
Right, like sort of a jarring thing to be as an engineer, suddenly thrust in this like, this math is very easy to do and very terrifying. But it kept the whole team motivated, despite the chaos. And then at some point in that, pandemic was ramping down, and I threw my hat in the ring in a few places, and one of them was another government fellowship, and it was this White House fellowship, a presidential innovation fellowship, sort of like mid to late career professionals come in and shake things up with the government. And I didn't know where they would place me, and they reached out the day after my wedding and were like, hey, we know it's been 9 months, but do you want to go to NASA and build AI? And when NASA calls, you just say yes. No? Right. I was like, oh, sure. And my wife was like, oh my God, you're going to be an astronaut. I was like, no, you can't say that. That's a totally different thing. But for like a good year, she would introduce me as her astronaut husband. I was like, no, like you really can't say that. And then, then I tried to give her examples, and the only example that stuck was Skynet. I was like, oh, no, I'm not building Skynet. Like you can't say that either. And then about a year into my time with NASA, OpenAI, not even a year, maybe 6 months or so, OpenAI comes out with GPT-3 and ChatGPT.
Oh, wow.
And suddenly it was like I came in expecting that I was going to have to use, what is now known as legacy NLP approaches. And suddenly there's like, I can get $1 billion model for cheap. I just need to get through security and get approvals and whatnot. But no, this is going to be the future. So it's a total game changer. But it also made it a lot easier because I could share ChatGPT with my wife and my my friends and and say, hey, no, this is what I do. They're like, oh, okay, now we get it. You're not an astronaut. You do this stuff. So for the last couple of years, I've been sort of working with NASA, trying to help them sort of the researchers and the scientists there integrate AI and now sort of best of breed AI and LLM into how they do the research and the science. And it is is sort of like a maybe not as chaotic as a lot of the other jobs I've had, but I think it is similar in that like we sort of we sort of quickly realized, and we can talk about this more, is like no one was doing what we were doing. And if they were doing it, it was so rare that there wasn't a lot of published research of like how to do it with AI at this scale, at this like level of complexity. And that was really exciting. And that's sort of why my 1-year fellowship turned into 3, now 4, and here we are.
Jeez.
So what are some of the things that you're doing with AI at NASA that you're able to share?
Yeah.
So I'm sure there's probably stuff that you can't talk about here.
So
won't press for that.
So the group I work for at NASA, so the Convergent Aeronautics Solutions project within the Transformative Aeronautics Concepts program within NASA Aeronautics. So like
we'll write that out.
Right. It's a small.
There's an onion here.
There is an onion, as with all government things. Nested like Russian nesting. I can't say Russian. Okay, nested dolls. But it's a small group, and what I would say is sort of like a DARPA group within NASA. And for those unfamiliar with DARPA, Defense Advanced Research Project Agency, so they do like the weird stuff for the DoD. Inventing robotic geckos that can climb walls. They were, had a big hand in inventing the early internet. It's like, hey, what if we make these computers talk to each other through phones? Crazy ideas, and then they go figure out how to make them work. And what I think was that was sort of a cool, cool group to get involved in, but they had not dealt with a lot of AI. And I think what they were sort of struggling with was this, man, if you try to get 5 PhDs in a room and they have PhDs in vastly different fields. And these are not like early PhDs. These are like people with 20, 30 years of experience, and they're world-class experts. This is NASA.
Right.
And you're saying, okay, now I need you to go solve this wicked problem over here. The problem won't come to won't be noticeable for 20 years, won't come to a head for 40 years, but will collapse humanity in 50. Go. And you give them really nothing else except sort of a vague notion that something terrible might happen in 50 years. Like that's really hard to wrap your head around. It's like, where do you start?
Right.
And what we were sort of trying to figure out is like, that is a different level of innovation and brainstorming and creativity and design work that just isn't common. Yes, a lot of groups do like forecasting and futurism, and they try to sort of backcast strategically, but very few then sort of say, hey, how do we start finding sort of linchpin products or innovations today that then may open up research tomorrow, that then like you're trying to sort of start this like cascade, this domino effect that might take 50 years to play out. And you only have so much cash, and you can only pick for so many things. So trying to be very thoughtful about that is a really hard problem. And I thought it was sort of AI can solve this from hopefully sort of at least play into this in sort of two ways. Is one, help you traverse this vast quantity of research. Basically, the scope of things that we had to deal with is anything and everything. And I'm not joking. It's like anything you read, any journal, any article, any trend, like what is happening in reality TV could be relevant, and you could make a case for it. And you got to sort of like play all that back, and then how do you filter that and find these are the whispers of a subtle trend that may converge 20 years out and then play out into this big problem. We need to understand that. And then you're talking about things that are not necessarily scientific. So they could be political, environmental, legal, all of these things all have a lens. And now you're trying to play that back to, again, a team of 5 PhDs who are scientists, and they've never done any of this. And you're like, okay, how do I make them successful? So AI had this, this element of, can we traverse this vast set of knowledge quickly? And that was something AI, I think, had traditionally been set up well to do. LLMs had been doing this. A lot of sort of vector search had been sort of the default top tier search solution anyway. Now the embeddings were just better. But now there's this other half of using AI to be more creative. And this is where I got excited. It was like, okay, can I get AI to imagine future scenarios that are credible based off of information, these sort of very whispers of trends, subtle trends that we're seeing? Can I get an AI to create really interesting futures? And then if it can create enough interesting futures, can I do it at scale? Like, hey, I'm going to create 1,000 futures. And then from that, help me then do the backcasting of 70% of them all talk about this underlying issue. Can we validate that is going to be a real problem? Because if it is, oh man, all these futures emerge. And like one of the things the example I use, sort of like how this can be powerful, is that AI is, if you can get it, AI is actually a pretty neutral arbiter of futures. Humans tend to be really bad at this. This sort of classic example is like in 2008, right? Bankers had financial projections, right? Really complex models. And then the crisis hit. Oh no, and everything's going wrong, and they're saying, oh well, this is so unlikely. According to their models, it was like winning. It was 25 sigma events, so it's like winning the lottery like 21 times in a row, and they had multiple 25 sigma events. And as a statistician, you look at that and say, okay, well, like either all of stats are wrong, or your model was wrong. And I love that a lot of them didn't face consequences. It's like, you published a model that really had this as a likelihood, and you still have a job. Okay. The reality is that the risks, they underplay the risks massively. So then when the risk actually played out, they were wildly unprepared. You can do this stuff, but like humans, I think, I sort of can be a little bit forgiving because like humans, we are naturally really bad at this. We don't want to look at the really terrifying futures. So we just always discount them. AI as the neutral arbiter can be like, no, like it's very likely that you could, have this terrible thing happen to you. And we're going to adjust that risk factor purely based on the data, on what we know. AI has no interest, like the AI model has no interest in telling you humans will thrive. It's like, oh no, like you might, and here's the ratio. So with that sort of neutral arbiter sort of capability and its ability to traverse lots of data, the trick was then, okay, how do we get it to actually be good at making futures? And this is where things got fun. It's like you're trying to basically induce hallucinations, and I call it like AI dreaming. Is like, I want it to hallucinate. I just, if I'm hallucinating, but I know when it starts and stops, it's like, oh, I went to bed, I dreamed, I woke up. It's a hallucination around which you know the boundaries.
Yeah.
But dreams can still be, useful. And that's where we're sort of inducing dreaming for AI. It's like tricking the AI model into coming up with real, really good hallucinations. And that, like, how do you seed entropy in the prompt, and like, what's the right temperature for that model to like get it? It ended up being actually not, like, temperature was not actually the big factor. It was actually high temperature was a problem, not a solution. But yeah, so like that's the sort of the cool stuff that we ended up doing. And now we're sort of productizing this and trying to make this sort of readily available, these sort of tools for NASA, hopefully for the public and the the other government agencies as well, because we think futurism and this sort of scenario planning is really valuable as a discipline.
For sure.
So we're already trying to like figure out and there's things that have been published, maybe not game-changing papers yet, but certainly for those in this space, we think it's pretty cool stuff.
Yeah, I was going to say this.
Cool.
It's interesting to hear that this research is and was going on, because this is something that I've been doing for myself for a while. Just plugging it in, plugging in like a bunch of information about like here's what I'm doing, here's where I want to go, like what are the odds that I actually make it there, and then and then it gets back to me like, no, you're an idiot. Like you need to do this and this and this instead. I'm like,
come on.
Actually, you're probably right.
It's because you're sort of swimming upstream against like two trends. That one, the LLMs are being trained to avoid hallucinations. It's like, well, I sort of want them sometimes. So they're trying to get better at that. They're pre-filtering some of that. And then two, they're trying to get really good at alignment. And alignment also, again, tells me what I want to hear. And the alignment, no matter what you do, because we're still training on human data, the alignment tends to be sort of very thoughtful about the human outcomes. It's like, but the alignment I really want is tell me if things are going to go wrong. I need to know that. I've been frustrated by even some of the sort of later models I see, and again, this is data, not real data, but like at least my anecdotal data, that like the newer models are avoiding having those conversations a bit more, and they tend to be like the bankers in 2008. They're like, we don't want to look at that, because that's probably not what you're asking. It's like, it is what I'm asking. Please, for the love of God, tell me about these terrible
what will
scenarios.
go wrong.
Right. Yeah. And then of course some of the scenarios. Yeah. Sorry. Go ahead.
Oh, I was just going to comment that Jake and I talk about that a lot on this podcast, that like, the models are all too willing to tell you that everything that you are thinking is, the most brilliant thing ever.
Yes.
I like to call it firing up the validation machine, because whatever you want validated, like you can get it validated. Whether it's accurate or not is another question.
I'm continually having to rephrase my prompts and my questions, because if I ask it, I'm trying to think of an example. Like if you ask, this is my goal, here are obstacles, do you think I can do it? It's going to come back to you and say, great question. You can definitely do it. But if you can, it's like you have to force yourself to be more objective and phrase your prompt that way, so it induces that objective view. I love, it's so interesting that you're talking about this, because I think this is, the hallucinations are like the archetypal problem with LLMs, that people are like, oh, but hallucinations, better not use AI because hallucinations. That's been the thing. And it's like you're taking that and you're saying, wait, this could actually be a huge gift to humanity.
Yeah.
And
there is value. You just have to apply it to the right problem. But again, even like we have, there would be scenarios where the hallucination is bad. It's like, oh, this is actually a non-credible future. This is not likely. So threading that needle of sort of inducing the appropriate amount of imagination is sort of where we had to sort of like a lot of trial and error as a team. Really, we worked hard, because if the temperature is too high and your prompt is sort of very straightforward, it's like, tell me about these futures, it ends up giving sort of very boring things. It's like, AI is coming and AI will be trusted, and then something go wrong and it'll be untrusted and it will be bad for humanity. And like it's a very like, cool, great. That's but why? Like, there's not enough nuance to do any sort of game theory around it. And then if the temperature is really high, and the prompt is poor, it just goes off into crazy land. Just like veers off that, like the cone of possibility is just, it's just straight out. It's the absurd. So what I thought was really interesting, and I was taking a class at MIT on futurism at the same time, and I was looking at sort of like the research coming out of the space, because it was not an area I had done a lot of work in before. It's like, okay, like I want to know what the best practices are for humans. And if you can get an AI to participate in what is effectively like a brainstorming exercise for humans, it actually turns out to be pretty good at playing a human role on a team doing futurism, even against itself or other AIs or other people. And like that was really like a light bulb moment. It's like, if you assume that the LLMs are trained on human responses, giving it sort of a human structure of a brainstorming exercise produced way better results in this sort of like induced hallucination. So one of the things we did is sort of like how, why laddering, and like actors like, hey, here's an article, and here, like give me all the players related to this article. And the classic example we've sort of talked about is like there was an article about like smart TVs being a platform for malicious actors. Okay, fine. In that article is referenced like there's the manufacturers, there's the users, there's external state actors who might want to leverage manufacturing and sort of like put malicious chips, etc. So like all these things are sort of referenced. The AI can pull those out. You can imagine maybe 2 or 3 that were maybe implied but not explicitly referenced, and then say, okay, just if this happens, like pick an actor and like what is their response? What are they likely to do? Just like their best guess, and then this, and then it's like, okay, well, randomly pick another actor, and then what would their response be? You do this. And for the first 3 or 4 are very predictable. And then by 5, 6, 7, 8, suddenly you start getting into like some really interesting things. But it's starting to create this narrative out into the future, where it is starting, like, oh, well, at some point, maybe it invents like a nonprofit group and it gives them like an incentive or a structure or a goal. Oh, well, like some nonprofit will spin up in response to this, because there's always going to be some sort of activist response. Oh, okay, like, oh, they're corrupted by the lobbying group here, and they're funded by this, and this is, a PR angle, and this state actor acts this way. And suddenly you start seeing like politics and human nature and things start to bubble out, which are the ugly things, but they're not tech related. And that was where I thought the beauty of this approach started to really like play out. And I think my favorite thing that I saw, and again, anecdata, not testable yet, but every time they brought up like teens, any group where there's like kids, they'd always like, oh, and then like the parents came out, and there's like like a satanic fright sort of a moment of like, oh, they're panicked about something. AI or this, whatever in the schools, and the local legislators clamped down on it, and then teens found a way around it. And that was always like, without fail, teenagers always did this. And I was like, if AI AI trained on the history of humanity and every writing that we've ever done, from like like Beowulf and Chaucer on forward, and everything, it's like no matter what, teenagers will always find a way around the rules.
They will find the loophole.
And I was like, this is really insightful. And now I judge like the credibility of like a good futurist scenario. It's like, yeah, but like, but what about the kids, man? What about the kids? What will they do?
You think about the teenagers. Yeah,
right.
Exactly.
It's like, what's that movie where like Red Dawn, right? It's like, oh, it's the teenagers,
Yep.
That's how we defeat the invaders. It's the teenagers in the woods.
Wow.
Yeah.
Well, that's okay. So your work at NASA then is kind of unique in that it's very futurism based. You're trying to help prep. So you said you're trying to productize these practices, like how are you working with off-the-shelf models for this, or is this like internally we've built this at NASA, or is this taking ChatGPT and working with that?
So I can't talk about specific models, but I can say that I think the federal government has, from current and past administration, have leaned in to the AI models. And I think they're trying to make them, all the commercial ones, readily available. Every agency has different contracts and accessibility, saying, oh, like if you're Azure, yeah, maybe OpenAI moves forward. I think almost every cloud vendor has a relationship with every agency. They've all sort of like you've got all 3. Pick the one that best meets your needs, because every vendor has subtle differences that when you're dealing with infrastructure and security requirements at the scale and specificity the government is, you might have a reason to go to one and not the other, but then you don't want to leave that environment to go hit a model somewhere else. So I think to date, there's been a lot of experimentation across a lot of models. That being said, when you are in government, and the government, NASA particularly, has been building big models for a while. I mean, I think for a few years, NASA had like one of the biggest, most powerful supercomputers in the world. Now it doesn't. There's always that leapfrog. I got to walk through a couple of them. They're like, oh, this is only the 8th most powerful computer in the world, right? It's like, oh no,
that's
right?
Not impressive at all. I'm leaving.
All right. It's like, but like number 6 is out in the yard, and you're like, what? And it's like, yeah, like they didn't want to move it in the building because the heat issues. So like it's actually like in a shed outside, which is like tubing and venting all around it. Like it's actually way more efficient to just have the heat column just not in the building at all. It's like it's
interesting.
Yeah. So like they're getting, NASA always been very smart about this sort of stuff.
Yeah.
So they've had a lot of AI, but LLMs specifically have not maybe been the focus for a lot of government agencies. Certainly not ones they want to share. So I do think this is an opportunity for government agencies, and I think again both administrations sort of leaned into this, and the policy sort of directs us like, hey, like we want to be at the top of this, we want to be leaning into this, and there are reasons that we would want to have our own models with their own specificity. I mean, using off-the-shelf models comes with a lot of like their wraparound, their final training layers, which remove a lot of bias. But that can also induce a lot of issues that if you're trying to get to raw things, has a problem with. And I think so. The example I say is like I talk about like in some of the speeches I give. There's a photo of like the 1958 Nobel laureates, right? It's all white dudes. Great, all white dudes. Nobel laureates. They're clearly very smart people. But one of the issues, like, okay, like, but why are there no women or people of color in the photo? And it's like not that they aren't capable. Those groups aren't capable of doing really great research, is that they weren't allowed to participate in the sciences. They weren't even allowed to attend school for much of that era. And like, that is not that long ago. And we have data, we are training on research papers and data that stretches all of that as well. So these models are trained on data that has been, for the majority of human history, like largely biased against a lot of groups. So you want to deal with that, right? You want to have that. You can't you can't like reinvent, you can't come a whole new earth with an unbiased history and say, hey, we're going to use that data. So the only way is sort of those fine-tuning layers at the end. It's like, great, you've got the core model is heavily biased. We're going to now fix it, try to tweak some of this at the end. But they also wrap around some things like removing, like national security issues and threats and bioweapons and all that stuff. But when you are trying to do things like plan for a terrible future, or you're trying to do something like, you actually do want to consider, well, what happens if a state actor plays with it's like, what happens if biochemists come with some like algae that spreads across the ocean and destroys all plant life in the ocean? Oh God, like I do want to think about that. So I think as agencies, as a government, they have a responsibility to sort of think about those trade-offs for every single project. So there isn't like a one-size-fits-all solution. Obviously, you're always going to have trade-offs, but at least at that scale, you are dealing with the trade-offs in a meaningful manner that maybe the commercial sector doesn't really care about. So I do think and that sort of makes sense for the investment in a lot of the government data centers. Like like building your own LLMs, having your own models with maybe their own fine-tuning at the end, specifically for the use cases that you're providing. It's like, hey, maybe this is a national security focused LLM that is actually tuned to really keep an eye out for those things that actually will bubble them up purposely. Is a pretty worthwhile investment, at least as an outsider. That is not what we're building. But it's I think government is dealing with that and trying to be thoughtful about that. And that is, that has been a great thing to see, is that like they are, no matter all the other things that are happening, like that has been like at least everyone is focused, like, yes, this is something we want to get ahead of for many reasons.
So I have a couple questions. First, so there's been, at least according to like a political compass type test, which, they're kind of memey and not that real, but there's a lot of those out there that show, ChatGPT, Claude, Grok even tend to be kind of center left in their political leanings. In your work, have you found that to be true? And two, if so, have you found that there's a bias in the other direction as well that needs to be tuned out, or is it mostly the classic bigotry and racism from past literature?
So I'd be interested to look at the research on the center-left framing. I would say that history always shifts the winners into the center-left. but the center moves.
Right.
Yeah.
Yeah.
So if you look at, I don't want to get too much into politics, but like,
yeah, I was going to say, I
yeah,
was trying to ask this question in a way that was relatively neutral.
Yeah, if you look at sort of like the history of the Vietnam War, right? In the midst of that conflict, in the early days, what you might see in the newspaper articles and support might not have been divided. Then it was deeply divided. Then it was very divided. Then, it became a huge political issue. Then you couple that with some of the race relations issues of the mid to late 60s, assassination of Martin Luther King. Like there's a period of race riots and some terrible things, all in the context of like a war that a lot of the US didn't want to be in. And now looking back, right, it's like, I would say it's a pretty centrist common opinion on both sides. Like, hey, yeah, maybe we shouldn't have done that.
Right.
That is not where the center was in the era. So I do think that the center left is sort of the transition point where sort of progressivism nudges and nudges and nudges, and history is sort of absorbed, and that's sort of where it anchors. So it would make sense to me that a model, even when it starts to aggregate those things and it starts to absorb what is like, what is the 2020 or 2019 or whatever, the early days of these model trainings, like 2025, like what is the thinking in 2025 on the Vietnam War, is probably going to anchor sound a little bit center left. So that does not surprise me, just from a like understanding of humans and how we have written about all of these historical things. I am not super worried about that particular bias. I do think there is an alignment issue, or there are alignment issues around sort of the broader things that the model is not questioning. And I tend to look for the more subtle problems in models. One of my favorite things is I go in and ask for like, give me the top 10 researchers in this field. And in the earlier days, I would almost always get like 9 white dudes over the age of 60, and then 1 woman whose name was made up and didn't exist. And I was like, oh, okay. Like I can see the model trying, right? It's like, I was like, and like, the reality of this ecosystem, right, of that scientific discipline is like, of course, like the top leaders, the people who will get Nobels, in 10 years, 20 years from now, are obviously way more diverse than that list. But the data is a little laggy. It can't quite estimate who is like within the community the actual leader versus the most recognized person of the last era. And, like it knows it needs to, I can't have all white dudes. I need to have a name that sounds like a woman because it can't tell race. So it tries like, like I think one I kept doing RAC, and it's like, okay, well, there's no male names that end in RAC. So just finish Rachel and then just come with a last name. And I was like, always made up. They have gotten way better. And they are like, but like that was like a subtle indicator in the early days of like, if I ask it for experts, if I ask for who's the thought leaders in this space, that is a much more nuanced bias to be trying to ferret out. And if you're particularly trying to take these, like what it thinks is like, what should I be reading to be well-versed on the current state of research? I actually do want to know not who's going to get the Nobel next year for work they did 20 years ago. I want to know who's going to get the Nobel 20 years, who published something last year. And like, that's a different ask. And it's not been great at that. I do think some of the agentic models that tap into some of the more recent, like combining some of the Google search and the Perplexity approaches, are doing way better at that, because they basically surrender to this idea that, our current data is out of date, and we've condensed it down enough that our first guess what is the latent knowledge sort of baked in there is probably not great. So let's just defer somewhere else. Let's go to something more recent that is more has much more clarity, and then just work it in and give it a nice paragraph explaining what we found. So I do think that is the way to get around it. So less worried about the bias because it is sort of working itself out in the way that the models are coming to market.
Yeah. I was just curious because like myself being, I'm kind of, again, we won't get deeper into this than this, but like, I'm center leftish. So I can't accurately judge whether or not that's, those political tests are accurate. So I was curious, from someone who's been doing research at a larger scale, if you had seen any of it. One other question that occurred to me. So one problem that I've had with LLMs and, using them to summarize articles, et cetera, research, and they've gotten better at this to be sure, but I find that sometimes LLMs have a hard time of picking out what is actually salient in a document or a set of information. Have you encountered that issue yourself, and what do you guys do to kind of work around that?
Yeah. So quick, I should have done this at the beginning. Quick disclaimer. All of my views expresses are my own views as a
right. Yeah.
not the official views of any government agency, NASA.
As an individual.
We'll put
a whole disclaimer on it.
Yes. Personal views as someone in this space, not the official views of any government.
Right.
Yeah.
Okay. Now that's
speaking for NASA. Got it.
Not speaking for NASA at all.
Speaking for James.
Speaking for James. Sorry, what was the question? Oh, documents, finding information. Yes. So in the early models that came out, that we were like, I remember sort of like hacking at basically an iterative loop agentic model, because mostly to get around the context window limits of like, oh, you only get like 4,000 tokens. It's like, all right, I got to run this 20 times. summarize, split, over and over and over again. And built a whole state management workflow, and graph display. I was like, how do I deal with this at scale? And then the windows just got way better, faster than I expected. And now we're back to agentic flow. I was like, oh, this is very familiar. I see the context window growth as a bit of a parlor trick and a cash grab. Because if you look at the context window length usage, like the quality of information retrieval in those longer windows just drops off a cliff.
Right, exactly. And there's the whole problem of like the huge dip in the middle too so it forgets all that information.
Right. So it's almost useless. And then it's like, oh, but what you really are hoping for, and I suspect these companies are hoping for, is like, yeah, you'll get a good enough answer, but we're going to charge you for those tokens anyway. It's like, hey, drop a million, 990,000 tokens in, and we'll generate the last 10,000, and it'll be a really robust sounding answer, and you'll trust it, and you'll automate around that, and we're going to charge you for that full million, even though 70% of the middle probably did not retain the attention as well as it should have.
Interesting.
I do think that if you're going to spend the money on that token usage, smaller windows, being more iterative, controlling memory outside of your flow, a shared memory across agents, multiple sets of memories. Like, hey, like I've been fiddling with my own work of like, I want different things to be remembered for different purposes. So instead of thinking about like, hey, is this a shared memory? It's like, like one memory across an agent implies that the agent can best decide and update that memory based on what it's doing. It's like, I'm going to treat different memories as different purposes and different tools. If I want to know something, like I'm like, if I, because before Cursor and all these things, I was sort of trying to build my own sort of IDE, complex code-based manager. And it's like, I want memory around document structure, around purpose, around the, like what the flavor and my rules are. All those are meeting different requirements and needs. So they shouldn't actually be treated necessarily as the same source of truth, because as they get updated, it's like, well, when you are updating, I want you to only be considering like the libraries that I allow you to use. I don't want you to be adding lots of other stuff. When you are considering the document structure, I want you to only be considering the flow and like what good document structure and folder structure looks like in my code base. So I do think that like as the agents start getting better, we're going to get to that multi-agent model. Then each agent's going to end up having sort of its own business value and memory around that business. And then this issue of like token windows will get a lot less meaningful. I think we're already seeing that, because like, do I really need everything, or can I just like shoot off what I want to be remembered to these various agents and then bubble them back up as necessary? And it's sort of a RAG across multiple business cases across via multiple agents running their own mini RAGs internally. And that's even how some of the NASA stuff we built. It's like we have lots of plugins, and yes, it's one vector store, but like each plugin is tagged like, well, it's searching its own subset, because how it does its embedding might be very different, because it's looking and managing and wants to search different things. The underlying structure of, oh, it's a vector DB, cool, that's the same. But how you search and what you search and how you created that embedding is probably different for every single use case. And why would I sort of force everything into one chunking strategy when like that's not optimal from like getting what I want out of it long term?
Interesting. Yeah, no, that's a valid point. This is kind of going back to this futurism idea.
Yeah.
Because I'm curious your perspective, as I'm sure
it's your jam.
It's my jam. But just with this whole background that you have, high level, where do you see the future of AI? Do you think LLMs specifically, I feel like recently we've been talking a lot about like, are LLMs going to be around long term? Is it going to be something else? Do you have any thoughts on what the future looks like for the AI space?
That is a big question, and it's one I think about. One I think about a lot. I have a couple predictions, and I think they are maybe mutually exclusive, which is hard. But it's like, hey, like I got to paint lots of them. I don't know. There are a couple linchpin moments, and I don't know what's going to happen first. But I would say that anything we've seen is that like the market is moving very fast, so trust nothing, and that every prediction is probably wrong to some degree. So if you are trying to do any sort of futurism and do some market planning and just making some recommendations to some corporate boards I work with, and nonprofit boards, it's like, hey, like here are 5 or 6 ideas. Some of them, again, conflict, but you got to think about like, what are the common investment strategies? Like, hey, these 4, we could build this, and this solves for these 4, build this, and solves for a different 4. You got to have that coverage. So make sure that you are wide with your scenario planning. So one of the things I think is, I thought that compute was going to be a bigger constraint than it was, but the CPU bound, CPU only models coming out of like China and the Quen models that can only run a CPU, like, yes, they are very slow, but the fact that they can run is still pretty impressive. And I was like, oh, okay, that opens up a whole level of compute. DeepSeek freaked out a lot of people, I think for the wrong reasons. They're like, oh, it's so cheap. I was like, no. It was actually, I think it was, backed by a hedge fund. Like it was still pretty expensive to build. What I thought was sort of and as I understand, is like, well, they built it with cheaper hardware. They didn't build it with the high end stuff. And like the fact that it could be done sort of upended a lot of what sort of I think was the US, the NVIDIA sort of market boundary. And I was like, oh, okay, well, if they can do it now, everyone can do it. And they also introduced a whole new approach, mixture of experts. Now that the mixture of experts is being absorbed and used by every other model, the question is, okay, well, then will others quickly leapfrog, and will there be yet another boundary that, the DeepSeeks and the Alibabas of the world not have struggled to get over? I don't know. But the fact that they broke through it once so quickly means that, you can't make a bet at 6 months out and have any hope of like really knowing where you're going to end up, outside of the fact that more money is going to get thrown into this. That is it. And that it is a highly frothy market. So being nimble with your resourcing is the only thing that is, I think, the stability bet. My brain did originally go to that the cost of inference is going to go up, mostly because the investment in these models is going to go, more people are going to want AI, so the demand is going to increase. Right. But we, from an infrastructure standpoint across the US, knowing nothing about tech, just saying, hey, how many data centers does the US want to build? How much energy and water do we actually have? And to say, oh, those 2 things do not converge in a happy place. That, I think, is going to be the thing that chokes our investment much quicker. And it's like, okay, well, now lots more people have the capability to run their own inference and want to run their own inference, but the compute capacity is, down. So high demand that doesn't exist today on individualized, I want to run my own model without the supply, because the supply will take another decade to catch up. Because you're building massive data centers, you've got to run fiber, you've got to run energy, you've got to run water. And even if you have all those things in place now, it's still a 5-year investment. And we're going to hit, I think the demand expectation on US power in the grid is like 3x in like 3 years.
Wow.
So right. So I was at an infrastructure conference, and there's some architects and people trying to think really thoughtfully about this, but like, the only way around this is like, okay, like, do we start building micronuclear reactors next to, like, because like 1 gigawatt scale data center is, I believe, like basically like 1 nuclear reactor, right? It's 1 to 1. That is the volume of energy that you need. And then you start thinking about the water usage, and it's insane. And then you say, okay, well, if I can't use water to cool it, because like energy is cheap in the Southwest, but water is expensive, and there's droughts and climate change, we have to worry about droughts and water. Oh God, can we use gray water? Oh, okay, maybe not. Okay, what do we do? So now you're thinking, well, maybe I should build data centers if I can use exhaust heat, can I build data centers in like North Dakota, because maybe there's a fiber optic line in North Dakota. They've got snow melt for some water, but they're mostly just really cold. And I can basically power an entire town worth of, like, hey, here's all of your heat for the entire town for a year, 14,000 homes. You just need to let us build a data center and you get jobs. Man, that's a win-win.
Right.
So like the only thing you need is fiber. So suddenly you're building data centers in North Dakota, and now you're like, all right, now I got to think of like human capital. How do I convince all of these engineers to go live in North Dakota when they've been living in sunny, SF and and Houston or wherever they are. So these are like, there's this confluence of like truly environmental physical constraints that are going to hit AI, that are going to change the nature of the game.
Yeah, that's fascinating. Yeah.
The only release valve out of that is say, okay, well, what if the inference? How do you disperse inference costs on electricity? Outward. How do you take like, instead of like what now we have a big data center, sort of the nuclear power energy version, and make it the solar power energy version where anyone can buy it. It's all at their house. And I can't imagine everyone having a server at their home, but I can imagine a rebirth of on-device models and like a rebirth of like the Amazon Alexa. Like they've already shifted the Amazon Alexa, they're like, they shut down that whole team and they're like, oh wait, no, never mind, we're doing it again. But they are not doing in the hardware space. They are like, I think they're partnering like Google and Amazon are partnering with JBL. And anytime like those two play nice together, like you got to realize that like something's afoot.
What is going on?
What is going on? And JBL's a big provider of these devices and speakers. So I imagine there's going to be some sort of partnership where it's like, hey, we want to own the API inference model. We might even burn it onto a physical chip to reduce that cost, where we sort of get like higher energy efficiency and the models slow down. Like we only need to update them, S curve here. They only need to update them every year or two. Fine. With every Christmas, we'll update the power of the chip. Same with phones. So now you got like burned in capabilities on the chips, which gets you better energy efficiency. Although Apple has other solutions. And now that inference cost, which was largely borne by data centers, can now be borne on the phone or the device itself. And they're only doing off-device searches or requests for things that aren't there, for like deep, for RAG search or for really complex inference. But almost everything can be done on device. And you've now this massive investment in data centers. Now we build them all, and then suddenly we don't need them again. It's you sort of don't know where it's all going to shake out, but everything is swinging so wildly. But I do think the environmental issues around just physically getting energy, water, and fiber to a location is at 3x the volume that we have now is going to be the biggest issue.
It's already massive, and the idea of 3xing that in 3 years, honestly, is hard to think that's even feasible to accomplish that in 3 years. And I think this is a theme we've often seen as we've had such a wide variety of guests on, is just the wide-reaching impact of AI that it's just funny hosting this because so many people we talk to, AI is their life. They eat, breathe, and sleep AI. But when you're so in it, it's easy to think only like accelerate progress, move it forward. And you don't think about, hold on, cross-functionally across the whole world. What are the waterfall effects here? Like, this isn't free. This is both financially, but also environmentally. This does have a very substantial impact, and I don't think it's being grappled with nearly enough by institutions.
No,
sorry, go ahead.
Oh, I was going to say, Jake and I make this point a lot that like he and I are both huge AI fans, really like enthusiasts, very big optimists too, but also we both get really annoyed with the people who are not willing to look at these problems and look them in the face. Like if we are going to keep accelerating, if we're going to keep moving forward, like we have to look these problems in the face. We have to solve them. And it's not a matter of like, we can't choose like, infinite acceleration, or like, that's not a choice that we have available. Like we have to solve these problems.
Right. And, do you want to solve them when like the cheapest, best, and easiest solutions are now not possible, or do you want to solve them a little earlier? But you end up having to sort of find these sort of coalitions of the willing across these industries. But but part of it starts with like just understanding that these implications are. There's a great project, climateinteractive.org. I'll give a little plug. I'm not associated with them, but I have a professor and a colleague who works with them. They have a En-ROADS, EN-ROADS, ROADS climate simulator. And they do some really cool stuff. So like, hey, like, yes, how do we solve climate change? How do we get these values down to below zero? But like, they're trying to discount like, okay, like what if AI takes off and we have this massive increase in energy demand? Like, what does that do? Okay, like how much money do we need to spend now? What if we wait 10 years? Okay, like, and they're trying to say, yes, we want to solve climate, and yes, we want to like allow AI to do this. Can we find mutually, convergent win-wins? And that's why I sort of love some of the architects getting involved. It's like, wait, like, what if you heat this town in North Dakota with the exhaust heat?
I love that.
It's like, instead of like just letting it go to the atmosphere, it's like there are these sort of strange win-wins. What if you invest in a micronuclear reactor in a town that, yes, if you try to do that like a micronuclear reactor in downtown Boston, there's probably going to be a fair amount of pushback.
Yeah.
But if you go to a small town that's maybe like socioeconomically a little bit more distressed, and they have high energy costs, and they say, yes, we'll give you basically free energy and free internet and free heat, but we guys got to build this thing here, and the likelihood of like meltdowns or anything is like minuscule. And then the newer models, like there's probably a lower like barrier for entry for just like building a public coalition of support in a smaller town.
Yeah.
And lower risk generally speaking, because you can have separate from the town. But I mean, some of the trying to think about like what are the political calculations around nuclear power investments in like and people's understanding as an influence to where AI goes. It's like it's a strange thing to have to sort of think about. But that is sort of where like AI experts and people who are building infrastructure have to suddenly start being energy experts and water experts. Mm-hmm. But if you're not looking at that, you are missing it. And I remind people that the 3x that I talked about is the planned demand. Whether those projects get built, don't know.
Right.
But even if they are built, I also want to remind you, like supply, despite what your micro econ and classes you took in college say, like supply and demand curves are rarely linear. So a 3x demand doesn't necessarily mean a 3x price increase, which you could probably account for in your budget, but like it could be a 10x increase. You don't know. We don't know.
Yeah.
Plan for chaos. And then like running locally doesn't necessarily, solve your problem, because your energy, it's not the cost of the AI, it's the cost of the energy will be underlying.
Right.
And that can influence a lot of like, what are the other industries where energy is expensive and their margins are going to, take a plummet because AI is just sucking it up and they've got the capital to just buy off the grid. So there's chaos, but I think we can figure this out, and AI can actually be helpful in planning some of these scenarios.
Yeah, that's what I was just thinking. It's like coming full circle. Mm-hmm. Like AI, there are so many things that we've talked about that I think lend to the remarkable nature of AI. One is we've talked about this before, and I think the closest, most recent thing that can compare is potentially the internet, how it impacted every industry across the board. But then what's so different about AI is it talks back. So we're having these problems, we're having to grapple with these things, and we can use the little creature that's caused it all to help solve it.
Yes.
We can talk to it. Yeah. It's wild.
Yeah. I do. Sorry, go ahead, Professor.
Oh, I was just going to say, I really like this vision too, that you're spinning of like, let's go put them in a small town in North Dakota somewhere. Because the problem that I've become really interested in lately is, the problem of like rural collapse, right? And it's something that I have become extremely pessimistic about. And I hadn't considered this vision of using the data centers, because a lot of the rural areas are, Montana, North Dakota, Wyoming, like places that are cold and barren. There's nothing there anyways. You may as well stick a couple data centers there.
And like the infrastructure is good enough now that like it doesn't need a lot of it has some jobs, certainly enough jobs to be valuable to those communities, but it's not like an insane amount. You're not going to destroy the economies. yeah, no, I do think there's like there are some win-win scenarios. You do have to think outside the box, and AI can be used to help you think outside the box if done correctly. And that's
Right.
I'm hoping why I'm excited by some of this research coming out of our team at NASA is that yes, if people start using it this way and start leveraging it this way, that we can all be better problem solvers and solving these sort of wicked problems that are sort of DARPA-esque but out in the commercial sector. And I have high hopes, but hope for the best, plan for the worst is sort of the.
Are you able to give us a little hint of when this research might be dropping? I'm super excited to read this.
There are a couple of papers already out around sort of like human AI, a lot of sort of human AI design collaboration stuff. And I know there are some things in the works sort of going through the approval process. I think there's sort of a bit of a mad dash in the last few months of like, hey, like let's try to just lock everything down, tighten it up, and then like just publish it. Because we didn't know, if the project would be funded, et cetera. But I think leadership has, I think, thoughtfully looked as like, okay, AI projects, maybe we want to keep funding those, fingers crossed. But I will let you guys know when anything hits the wires. But I mean,
that'd be fascinating.
NASA does publish a lot of like there are technical papers coming out of NASA, and it's crazy how much like patented by NASA, but like fully, effectively free to license and use stuff. Like it blows my mind how many VCs just like, why aren't you trolling NASA websites? Like, cause they just publish stuff. They're like, hey, yeah, like we can't make money off of this, but here's a solution to like this massive market problem. Best of luck.
Gosh, new business plan.
Right.
It's like we had a guest on. We've had a guest on a couple times now, and last time we had him on, he was like, we asked him, what advice would you give to like aspiring entrepreneurs? And he's like, dude, like there's a million research papers out there that nobody has read, and there's free money inside them. You go read the research papers, you make a product implementation of the paper, and you sell it.
Right. Like if I were designing this prompt, it'd be like, okay, like dear LLM agent, please take this paper, which just got published. It has some interesting IP, unpack it, help me understand it, go do research on like what would be relevant industries, what are market gaps in those industries, and how this paper might be solved, and just come up with 10 business plans. Just go. And like, just automate, just like crawl every night, wake up, 10 business plans, like, oh, that's bad, that's good, that's interesting. There is so much good research, and I call it like the research industry, like it's exhaust. It's like we're just putting out this exhaust, and almost none of it gets picked up by investors. But there's easily billions of dollars of market value out there just sitting. But maybe because the people designing the websites didn't design it for the best Google crawling or like it's not
many business nuances.
Right.
For sure.
But yeah, though it's certainly worth looking at for sure.
Yeah, no question. I mean, I'm going to do that tonight, probably. If the podcast ends, it's because I found a killer idea.
If you need a CTL, let me know.
I might call you, James. I know we're kind of getting close to time here, but Spencer just mentioned this question, and we always like to ask it, especially where you actually have. I feel like you are where a lot of AI founders want to be. You've seen success, you've been in the field, and this is you're making a living off of this AI field and what you're doing and this passion. So what advice would you give to AI founders that are either just starting or trying to build a company in this AI space?
So I have made this mistake, sort of the build before buy, or build before you really talk to a customer. Made that mistake many times. Some really cool tech that no one wanted. I would say build in the early days because you're curious and challenge your curiosity. Don't build with a potential customer in mind. Build to a actual customer. So go out, find someone who has a need, and like get a sale, get like a letter of intent. Hold yourself to that standard. It is hard, particularly as engineers who don't want to go out and want to talk to people. Like it's hard. I put more faith in my ability to build the right tool than I do in my ability to like talk to lots of random strangers to find business problems.
Yeah, you're like, that's way harder.
Right. It was way harder. And it took me a career length of time to get good at that, because like what I find is like you find one customer and then they give you an idea, and then you find the second customer and the third customer. And by that, you find that like 70% solution is actually the root of all of their needs. But like once you have those real conversations, you start talking about like, well, like what's the reasonable price points? Can I, like, even if I built this, is it sustainable? Like what's the, there are very simple business equations. Ask AI. It will help you walk through this stuff, right? Cost of goods sold, customer acquisition costs. Like these are very simple things that AI can help you with that are a lot harder to knock out and do up front, but get comfortable cycling through 15, 20 of those ideas. Just like keep going out and asking, having those conversations and getting out of your house, of your office. To find those solutions. And then when you find something that like, oh, there's a real pain, no one's talking about it, you think you could solve it with AI, then build the thing. And that is just way harder to do. And on the flip side, what I found is sort of the same problem exists in business is like, I usually get brought in to build someone pitches me a tech problem. But usually when I get in there, it's a process problem. The process problem is usually a teaming problem. The teaming problem might be a culture. We hire the wrong people and they know the wrong things and they don't know what they're supposed to be doing the right way. And these are things that AI can help with even internally, but this idea of like people understanding and being able to talk to people in a sort of a candid and open way, build empathy that like, I want to actually help you solve your problem. I'm not here to hurt you. I'm here to help you. But being able to have that conversation inside the business once you are like, if you've scaled up, and also when you are starting a business, it's the same conversation. So get really good at that. And then suddenly I suspect your career will take off. Because if you can have those conversations and identify people's real needs and be trusted as like, I don't care what you build or how you build it or how you solve it. I don't care if you use AI or not, but you made my life easier. I will pay for that. If you can be the person who's reliably solving their problems, you will always have work. But that's not saying like don't keep hack it. I still code. But it's stay hands on keyboard so that you understand the art of the possible, particularly in a space like AI that's changing.
Yeah, that's good. Yeah,
but that's not the skill that necessarily you need to be building as much over time. Trust that you've got that. Work on the skills that maybe you need, which is almost always talking to people. Go talk to more people.
Love it. Well, James, this has been awesome. Spencer, do you have any other questions before we?
No, I got all my questions out. We'd love to have you on again, though.
Yeah. It sounds like the future is, going to be exciting for you, James. So we want to stay in contact.
Yeah, please do. I'm always getting into, hopefully not trouble, but getting my fingers in lots of weird pies. Almost all of them are AI related these days.
Excellent.
Please stay in touch. And I got lots of friends working in this space who are doing weird, cool, fun stuff. So I'm happy to
have them all on.
Put you in contact. Yeah.
Weird cool stuff is right up our alley.
That's our niche.
That's our bread and butter.
Cool. Yeah. Great.
Well, James, thank you so much.
Yeah, exactly. If people want to follow you, what's the best? Is it X? Where should people follow you if they want to keep up?
I'm still on Twitter /X, LinkedIn. I'm around. Those are probably the easiest ways to get in touch. I'm on Instagram because my wife makes me. But yeah, X. Yeah. I guess we can put the link in
the profiles.
Notes. Cool. Yeah.
Okay. Alrighty. Thanks, James.